Hi everyone, in this video we are going to discuss about the parametric form of the equation of a straight line. It is also known as the distance form, sometimes also it is called the symmetric form. Now let's try to find out what is that parametric form of the equation of a straight line is. In this diagram, we have taken a straight line which is in the blue color, and the angle of inclination of this straight line is theta radian or theta degree, whatever you want to call it, and the straight line passes through a given point r whose coordinates are x sub 1 comma y sub 1, and we have to find out the parametric form of the equation of this straight line. So two pieces of information have been provided. The straight line passes through a given point r whose coordinates are x sub 1 comma y sub 1, and the straight line has an angle of inclination which is equal to theta degree or theta radian. Now let's take a point P which is a moving point, and let's assume that the coordinates of point P are x comma y, and also let's assume the distance of P from the given point r is equal to lowercase r units, and we will try to express the coordinates of the point P in terms of r and theta, and that is when we'll get the parametric equation of this straight line. So how are we going to express the coordinates of P in terms of r and theta? Well, let's draw a quick little triangle here. So what I did, I drew a line parallel to the x-axis from R up to Q. So RQ is a line segment which is parallel to the x-axis. And then I dropped a perpendicular from P onto RQ at the point Q, of course. That perpendicular is PQ on the line segment RQ. So now, since RQ is parallel to the x-axis, then the angle QRP will also be theta. So we can indicate right here that this angle would also be equal to theta degree or theta radian. And since RQ and PQ, they are perpendicular to each other, this angle would be 90 degree. The angle PQR, that angle would be 90 degree. So this is a right triangle. The triangle PQR is a right triangle. Now for this right triangle, can we find out what would be the cosine theta and sine theta? Well, cosine theta would be RQ over RP. Now, what is RQ? Well, RQ would be the difference of x and x sub 1, because x is the x coordinate of P and x sub 1 is the x coordinate of r. So RQ would obviously be x minus x sub 1. So let me write it here. And what is RP? Well, we have assumed that RP distance is r unit, so I'm simply writing the lowercase r there. And from here, can we say that x minus x sub 1 over cosine of theta is equal to r lowercase r. Also, let's try to find out what would be the sine of theta. Well, we can say sine of theta would be equal to PQ over RP. And what is PQ? Well, PQ is actually the difference of y and y sub 1, because y is the y coordinate of P and y sub 1 is the y coordinate of r, which we can assume that it would also be the y coordinate of Q. So it would be y minus y sub 1, that would be the distance PQ. And what is RP? Well, RP is nothing but the lowercase r. From here, can we say that y minus y sub 1 over sine of theta is also equal to lowercase r. And now if we combine these two equations, x minus x sub 1 over cosine of theta, that is equal to r obviously, and similarly y minus y sub 1 over sine of theta, both of them are equal to r. So can we write two equations combined together like this? And that is the parametric form of the equation of this straight line. Now in this form, what is the parameter? Well, parameter is the r. Why? Because from here we can express the value of x and y in terms of r and theta. And r is the parameter which can be adjusted based on our requirement, right? Now from here, what would be the value of x? Well, x minus x sub 1 over cosine of theta is equal to the parameter r, and from here we can say, well, then definitely x minus x sub 1 is equal to r times cosine of theta. And from here we can say then x is equal to x sub 1 plus r times cosine of theta. So we have found the value of x. Now let's also try to find the value of y. So we had y minus y sub 1 over sine of theta is equal to r, and from here we can say y minus y sub 1 is definitely equal to r times sine of theta. And from here we can then say y is equal to y sub 1 plus r times sine of theta. So we have been able to find the value of y also. So now we clearly know the coordinates of the point P. So can we then say that the coordinates of point P are kind of like this? that is the x coordinate, and y coordinate would be y sub 1 plus r times sine of theta. And because we are able to express the coordinates of the moving point P in terms of theta and r is actually called the parameter. It is a variable in terms of which the coordinates of the moving point P can be expressed, right? So that is why r is called the parameter. And that is why this form up there, that is called the parametric form of the equation of straight line, because it has been expressed in terms of r. X sub 1, y sub 1 and theta, they are given information. However, r is the variable, and that is why that equation is called the parametric form of the equation of a straight line. I hope it is clear up to this point. Now we are going to take another situation where P is on the left side of R. So far we have taken P on the right side of R. Let me go back to the diagram. So here P is on the right hand side of R. If we draw a vertical line through R, then we can clearly see that P is on the right hand side. Now we are going to take another situation where P would be on the left hand side of R, and then let's see what happens. So in the second scenario, let's assume that P is on the left hand side of R, and its coordinates again x comma y, and R's coordinates obviously x sub 1 comma y sub 1. And the angle of inclination of the straight line is theta, same as before. So I'm writing it theta right here. So now again, I'm going to create a quick little triangle here using P and R. So let me draw the triangle. So I drew a line parallel to the x-axis from P, and the line segment is PQ, and then also I dropped a perpendicular from R onto PQ, and they both met at the point Q. So Q is the point where both the line parallel to x-axis and the perpendicular line from R, they both met each other, right? So that's the point Q, and obviously the angle PQR would be a right angle, because those two line segments are perpendicular to each other. And also this angle, the angle QPR, that will also be equal to theta, because they are the corresponding angle between two parallel lines. If we assume that the straight line itself is a transversal for the two parallel lines, one of them is the x-axis and the other one is the PQ line segment, then that angle RPQ, that is a corresponding angle of the original angle theta. So for this right triangle, again we are going to find out the value of cosine of theta and sine of theta. So let's first do the cosine of theta. We can say cosine of theta is going to be equal to PQ over PR. And in this case, what is PQ? Well, PQ is obviously x sub 1 minus x, if we consider the x coordinates there. So PQ distance would be x sub 1 minus x. Why? Because x coordinate of Q will be same as x coordinate of R, and that will be x sub 1, and then x coordinate of P is x. So the distance PQ will be x sub 1 minus x, and over PR. What is PR? Well, PR is equal to the lowercase r, that is our parameter. So from here, can we say that x sub 1 minus x over cosine of theta is equal to r. Similarly, let's try to find out the sine of theta. So sine of theta can be written as rq over rp. Now what is rq? Well, if you think about it, rq will be y sub 1 minus y, because the y coordinate of q would be same as the y coordinate of p, so that is y, and the y coordinate of r is actually y sub 1, which is greater than y. So rq distance would be y sub 1 minus y. And what is rp? Well, rp is nothing but the parameter lowercase r, and from here can we then say that y sub 1 minus y over sine of theta is also equal to the parameter r. And if we combine these two equations, then the combined form can be written like this: x sub 1 minus x over cosine of theta is equal to y sub 1 minus y over sine of theta is equal to r, and this is also a parametric form of this equation when p is on the left hand side of r. Now from here, let's try to find out the value of x and y. We have x sub 1 minus x over cosine of theta is equal to r. So from here we can say that x sub 1 minus x is equal to r times cosine of theta, and then from here we can say negative x is equal to r times cosine of theta minus x sub 1, and if we multiply both sides by a negative 1, then it will be x equals x sub 1 minus r times cosine of theta. So we have found the value of x in terms of x sub 1, r and theta. Similarly, let's try to find the value of y. Now I'm going to write on the left hand side here. So y sub 1 minus y over sine theta is equal to r, and from here we can say, well, then y sub 1 minus y is equal to r times sine of theta. And from here, if we do the same trick, we can say then y would be equal to y sub 1 minus r times sine of theta. So here we have found the value of y in terms of y sub 1, r and theta. So in this situation, what would be the coordinates of p? Well, we can say then p's coordinates can be written like this: x sub 1 minus r times cosine of theta, that's the x coordinate, comma y sub 1 minus r times sine of theta, that's the y coordinate. But previously we saw that the coordinates of p came out to be something like this: x sub 1 plus r times cosine of theta and y sub 1 plus r times sine of theta. And here we see that there is a minus sign here. Here we are seeing a minus sign. Well, then can we conclude that this will be plus or minus depending on the position of p with respect to r? So now I am going to change this to a plus or minus. So let me use a different color here. So I am changing this to a plus right here. I am going to say plus or minus, and similarly I am changing this also to a plus or minus. So let's say this is plus or minus. So the coordinates of p would be like this. So if p is on the right hand side of r, we are supposed to use the plus sign, and if p is on the left hand side of r, then we are supposed to use the minus sign. So all you have to remember is the position of p with respect to r. If p is on the right hand side, we are going to use the plus sign. If p is on the left hand side, we are going to use the minus sign. I hope everything made sense so far. Now we are going to take an example and see how to utilize this parametric form of the equation of a straight line to solve certain problems. So let's take an example. In this example, we have been given a straight line B which is inclined at 45 degree with the positive direction of x-axis, and also it passes through a point R whose coordinates are 1, 2. The question here is, there is another straight line which is straight line A whose equation has also been provided, and that straight line intersects the straight line B at point P, and we have to find the distance RP, meaning how far away from R the straight line A would intersect the straight line B. That is the question. So essentially we have to find the distance between R and P, and let's assume that the distance is lowercase r, which is the parameter from the parametric form of equation of the straight line. We know that the parametric form of equation of a straight line, in this case we are concerned about the straight line B, so its parametric form is like this, and in this example theta is actually 45 degree and x sub 1 is actually 1, which is the x coordinate of r, and y sub 1 is actually 2, which is the y coordinate of r. So then we can write it like this: x minus 1, which is the x coordinate of r, over cosine of 45 degree, that is equal to lowercase r, and from here we can say that x minus 1 is equal to lowercase r times cosine of 45 degree, and this can be written as lowercase r times 1 over square root of 2, and from here we can say then x must be equal to 1 plus r times 1 over square root of 2, or we can write it as 1 plus r over square root of 2. So that is the value of x. Okay, similarly let's try to find the value of y. Well, for y again, can we say that y minus, what is y sub 1? Well, that is the y coordinate of r, that is 2, over sine of theta, in this case it is 45 degree, so sine of 45 degree, that is equal to r, and from here we can then say that y minus 2 is equal to r times sine of 45 degree, that is equal to r times 1 over square root of 2, and from here then we can say y must be equal to 2 plus r times 1 over square root of 2. So now we have found the value of x and y, and because x and y are the coordinates of the point P, which also is located on the straight line A, that means the coordinates of P also will satisfy the equation of the straight line A, and we already have been provided with the equation of straight line A, that is x plus y minus 12 equals 0. I have written that up above there on the left hand side. So that is the equation equation of the straight line A, which is x plus y minus 12 is equal to 0. Now since P is a point on the straight line A as well, so P's coordinates must satisfy that equation, and in that case we are going to plug in the value of x and y in the equation there. And what is the equation in this case? Well, the equation is like this: x plus y minus 12 is equal to 0. And if we plug in the values of x and y here, so what is x in this case? Well, x is like this right here. Let me highlight it. So this is x and this is y right here. Alright, so we are going to use the values of x and y in this equation. So x is actually 1 plus r over square root of 2, that is x, plus y is actually 2 plus r over square root of 2, and minus 12 is equal to 0. And from here what do we get? If we remove the parenthesis, so this is 1 plus r over square root of 2 plus 2 plus r over square root of 2 is equal to 12. And from here if we keep the r terms on the left hand side, so it would be r over square root of 2 and another r over square root of 2 is equal to 12 minus 1 minus 2, and that is equal to 12 minus 3, that is 9. And from here what do we get? 2 times r over square root of 2 is equal to 9. And from here we can say, well, then this is square root of 2 times r, or we can say r times square root of 2, because 2 over square root of 2 will reduce to just square root of 2, so that is equal to 9. And from here we can say that then r must be equal to 9 over square root of 2, and that is our answer. We are supposed to find the distance from r to P, which is the lowercase r, and we have found the value of the lowercase r here, and that is equal to 9 over square root of 2. And if you carefully look at the equation of the straight line that I used here, the parametric form of the equation there, let me highlight that also, which is way up there. I took the first form because in this case P was on the right hand side of r. Now if P is on the left hand side of r, then we have to use the other form. There are two forms that I discussed there, when P is on the right hand side and P is on the left hand side. In this case, in the diagram, as you can see, P was on the right hand side, so I used that particular form. And then after solving, we can see that r is equal to 9 over square root of 2. So this is a very handy tool to solve this kind of problem, and this particular form of the equation of straight line is called the parametric form, or the distance form, or even sometimes it is called the symmetric form of the equation of straight line. I hope everything made sense. Thank you for watching. See you in the next video.